Okay, um, let's try another example. Solve tangent of theta minus pi over 2 equals 1. Alright, let's see. Again, we have some angle in here. I can still find where the tangent of that angle is going to be 1. So I'm going to use method 2 here. You can use method 1 if you want, but I'm going to use method 2 because I'm a little bit more comfortable with that, okay? Alright, so let's find out where is the tangent of an angle equal to 1. Alright, well, if I draw my unit circle, there's my circle. Where is it going to be equal to 1? Well, I know it's going to be when the sine and cosine are going to be the same. Okay, sine and cosine are the same at what point? Well, it's going to be right at 45 degrees, isn't it? At pi over 4. Okay, so when pi over 4 is my angle, then my tangent is going to be equal to 1. And also, it's a positive one, so ASTC. So the tangent is also going to be positive over here when my reference angle is pi over 4. So it's going to be really theta minus pi over 2. That angle must be equal to pi over 4, or, and I'm going to go ahead and write on a second line here just to save some space, and you can do this as well. Okay, but really it's two equations combined into one. Theta minus pi over 2 equals pi over 4, or this angle, right? What's this angle from here to here? Well, that would be pi over 4 plus pi. That's 4 pi over 4 plus pi over 4, so that would be 5 pi over 4. Okay, so there's two places there where this angle is going to give me a tangent of 1. Alright? Now, if I'm still not done because I need to, before I can check where to start from and where to end, I need to change this domain, right? Because I've restricted my domain in here, and our method said, let's go ahead and write this inside the middle, and then just change the outside parts to reflect the change in the middle. Okay, so this is 2 pi over here. So since I've taken pi over 2 from the middle, I need to take pi over 2 from here. So that would be 4 pi over 2 minus pi over 2, which would give me 3 pi over 2. And that would be 0 minus pi over 2, so that would be minus pi over 2 over here. So now this is my new domain, okay? And this is the domain that I'm going to use when I turn my when I look for whenever I hit my when I use my unit circle. Okay, so what I'm going to do is I'm going to start from minus pi over 2. Okay, I'm going to start from minus pi over 2, that's down here. I'm going to turn until I get to 3 pi over 2. Okay, so I'm going to go from here to here, and every time I hit my points that I've drawn on my unit circle, I'm going to write them down. Okay, so now I'm going to go from here, I go all the way up to pi over 4. I already have that written down, so I'm going to skip that. I'm going to come back down here, and remember I need to come back to here. I need to come back to this. This is my starting point and my end point. So hit here and hit here, and I come back here, and really there's only two answers right here, right? So those are my two answers that I'm going to have, but I need to get it in terms of theta, because right now they're in terms of theta minus pi over 2. So I'm going to move this to this side, and I get theta equals pi over 4 plus pi over 2, and 5 pi over 4 plus pi over 2. So those would be my two angles there. If I change this to the same denominator, okay, now I have 1 plus 2, which is 3 pi over 4, and 5 plus 2, which is 7 pi over 4. Okay, so this is my solution set. These are the two angles that will make this statement true. Okay, so it's really important here that you understand what's going on with this method. If this method does not make sense to you, you are free to go to the textbook and look at their method with using the general formula. Okay, all right.